Okay, let's look at, we've done some titrations back in the fall, but let's take a look now at doing some quantitative calculations with the titrations during the process of titration. Like, how do we figure out during the titration process what the pH is at any given point? All right, so here's a couple of terms, and we've seen these before. Okay, you should be familiar with these, just kind of a refresher there. All right, so this is the titration process. Very familiar with that one, using phenolphthalein. Okay, so let's look. One of the things that we did not do back in the fall is look at a plot of the pH versus the amount of your titrant that's been added. Okay, so here's an example. This one is a strong acid, strong base titration. That's what we've done before. And you can see here we have, if we were to monitor the pH throughout the titration process, all right, then we would see that right when we hit neutralization, right there at that equivalence point, all right, we're going to get, there's our maximum change in this curve here. Okay, that's our equivalence point, and so we could find the pH at the equivalence point by looking at this this curve here. All right, now let's look at how do we know what is being titrated. If it didn't tell us, how would we know? Well, we would know that we're titrating an acid because it starts out with an acidic pH, and we would know that it's a strong acid, strong base titration because of the shape of the curve. In a strong acid base, you're going to get, well, two things. You're going to get a very steep curve. The change is going to be very dramatic here at the equivalence point. And also the pH, if it's a strong acid, strong base titration, the pH at the equivalence point will be 7. So two ways to know from looking at the curve. So here's an example of what this one is. All right, now let's look here. What do we notice? Shape of the curve. All right, you'll notice here, see how we get the approach is a little bit, not quite as direct. We kind of, and what's happening here, when we have a weak acid, strong base titration, and let's take a look for an example here. Say I'm titrating acetic acid. Well, as you are titrating the weak acid, you are making a salt that has its conjugate base. So when we're doing these titrations, we are basically making a buffer solution in this part of the curve. All right, so we have some buffering going on at that before we hit the equivalence point. All right, now for weak acid, strong base titration, our equivalence point, we're making the conjugate base. So at the equivalence point, we have none of our acid or base. They're completely neutralized, so the only thing present is the conjugate base, the salt with the conjugate base in it. And so when we're titrating a weak acid, our equivalence point is going to be above 7. So again, we can tell that starting here, it's a weak acid because we're starting acidic, and based on the shape of the curve here and the fact that the equivalence point is above 7, that tells us we are titrating a weak acid. Okay, now here's something to note when we're titrating a weak acid or a weak base here at the halfway point. So if we were to look, so here is our, all right, equivalence point here occurs at about 25 based on right there. All right, the pH is equal to the pKa at the halfway point. So for acetic acid, it says the pKa is 4.74. So that would put us at about here. All right, and if I come about to there and drop down, if this were a little more detailed graph, you would see that that is at about 12.5 milliliters of the sodium hydroxide added. All right, so why does that happen? Oops, let me go back. All right, if you look, remember we said Henderson-Hasselbalch. Okay. Now, as we are titrating, all right, as we're titrating, in this case our acid, okay, initially we have all acid, no base. As we start to titrate, we're making base. At the halfway point, we have consumed half of the acid, or neutralized half of the acid, which means that the amount of acid and the amount of its conjugate base that are in solution are equal. Okay, so that's why here we get log of 1 is 0, and the pH would equal the pKa. So that's where that particular thing comes from. And here's another curve. This is our strong acid, weak base titration here. And you can see it starts up here. All right, at the equivalence point, it's going to be acidic because we are making a salt with the conjugate acid. So at the equivalence point, we don't have any of the base left. All we have is the salt with its conjugate acid, which means our pH is going to be acidic at the equivalence point. Okay, and again, this is showing you how that works. Also, if we're doing a weak base, okay, for ammonia, our pKa is 9.25. And again, here our equivalence point was at 25 milliliters. So if we go to 12, somewhere around there where we would find 12.5, if I'm going up straight, should be at about 9.25 there. Okay.